Welcome back students, this is lecture number 6, apparent depth and normal shift. We are discussing the phenomena refraction of light. Okay, so what is the apparent depth and what is the normal shift? बहुत बार आपने देखा होगा कि जब हम कांच के किसी बाउल के अंदर आप अगर पेंसिल को डिप करके रखें तो हमें ऐसा हम ऐसा इमेजिन करते हैं, हम ऐसा इमेजिन होता है कि जो आपका पेंसिल है वो टूटा हुआ है. ओके, सो व्हाट इज़ द रीज़न बिहाइंड दैट? द रीज़न इज़ रिफ्रैक्शन ऑफ लाइट. ठीक है, या कभी आपने देखा होगा, बेस्ट एग्जांपल है कि आप कांच के एक बाउल के अंदर अगर आप कोई कॉइन डिप कर दें और अगर आप उसे थोड़ा सा एंगल बनाते हुए देखें तो जो कॉइन है वो आपको एक्चुअल पोजीशन से थोड़ा सा ऊपर उठा हुआ दिखाई देगा. ठीक है, सो उसी के लिए यहाँ पे हमें एक डेरिवेशन फाइंड आउट करना है. व्हाट दैट इज़ एपरेंट डेप्थ, actual depth, apparent depth and normal shift. The depth of an object immersed in water appears to be lesser than its actual path. Okay, so यहाँ हमने एक छोटा सा कांच का बीकर लिया हुआ है जिसमें वी हैव वन कॉइन. ओके, so xy is your surface of water, OA is your actual depth and O dash A is your apparent depth. Okay, clearly OA is greater than O dash A. ठीक है. Okay, so here if you are observing perpendicularly, so this is will be your angle incident ray. So there is no angle of incidence, that is the value of angle of incidence will be 0, so the angle of refraction is also 0, so this ray will be returned back following the same path. But if we are observing from here, okay, see this is your human eye, if you are observing from here, so the incident ray is traveling from rarer medium to denser medium. Okay, rare medium to denser medium, so it will little bit bend towards the normal. Okay, so this will be your refracted ray, angle of incidence, angle of refraction. Okay, angle of incidence, angle of refraction. Okay, सो एक्चुअल जो है आपको ये जो आपका इंसिडेंट रे है इसको ये पथ फॉलो करना चाहिए था, बट उन्होंने फॉलो कौन सा पाथ किया, ये वाला पाथ फॉलो किया. ओके, सो एक्चुअल में जो आपका इमेज है ड्यू टू द रिफ्रैक्शन ऑफ लाइट, यहाँ पे क्या होगा, ये जो हमें कॉइन का इमेज है वो कहाँ पर दिखाई देगा, हमें ओ डैश पे दिखाई देगा. ओके, सो दिस विल बी योर एक्चुअल डेप्थ एंड दिस इज योर apparent depth. O dash A is your apparent depth and OA is your real depth. Okay, so O dash is the virtual image of O. Okay, clearly BOA, you can see in the figure, angle BOA equals to angle OB and dash, that is I, alternate angles, and AO dash B equals to CBN equals to R, corresponding angles you can see in the figure. Okay, so next one is in triangle OAB. What is angle OAB? This will be your triangle OAB. So from here you can calculate the value of sin I. Sin I equals to AB upon OB. AB is your perpendicular and OB is your hypotenuse. Okay, next one is O dash AB equals to sin R. O dash AB sin R equals to AB upon O dash B. Okay, as light ray is traveling from denser medium to rarer medium, so from air to water, so A mu W equals to sin I upon sin R according to the Snell's law, and A mu W equals to AB upon OB dash O dash B into OB upon O dash B. Okay, O dash B and O dash B will cancel out. Sorry, if the point B is close to A, so OA is approximately equals to OB and O dash A is approximately equals to O dash B. So A mu W equals to OA upon O dash A. OA is your real depth and O dash A is your apparent depth. Okay, if X is the real depth of water, suppose that real depth is small x and a mu w is the refractive index of water with respect to the air, then the normal shift d in position of point object, that means जो नॉर्मल कितना आपको शिफ्ट कितना वो ऊपर दिखाई दे रहा है, दैट इज डी. डी इज व्हाट, रियल डेप्थ माइनस एपरेंट डेप्थ. ओके, so d equals to real depth is what, real depth is x, and according to the formula apparent depth is what, real depth upon apparent depth. So real depth is x and apparent depth is what, a mu w. ओके, apparent depth का अगर हम यहाँ से इस फॉर्मूले से वैल्यू कैलकुलेट करेंगे तो रियल डेप्थ अपॉन a mu w, so x minus x upon a mu w. So d equals to what, if we take x as a common, so 1 minus 1 upon a mu w. This is your normal shift. Okay, this will be your normal shift. Okay, now taking one example. Suppose that velocity of light in a glass is 2 into 10 to the power 8 meter, and in air it is 3 into 10 to the power 8 meter per second, and we have to calculate how much would dot appeared to be raised when covered by a glass plate 6 centimeter thick. Okay, so here we have velocity of light v equals to 2 into 10 to the power 8 meter per second in glass and 3 into 10 to the power 8 meter per second in air. So refractive index a mu g equals to c upon v. By this formula you can calculate the refractive index a mu g, that is 3 into 10 to the power 8 upon 2 into 10 to the power 8, that is equals to 1.5. so refractive index is 1.5. the thickness of the glass plate will be 6 centimeter, is 6 centimeters. So shift in position is what, t is your 6, so d equals to 6 into 1 minus 1 upon 1.5, so it becomes 6 into 0.5 upon 1.5, so it becomes 2 centimeter. Okay, so I hope you will understand this particular derivation. Okay, this is very important, and maybe a question may be asked from this particular topic. Okay. Okay students, our next topic is critical angle. What is the critical angle? The angle of incidence in denser medium for which angle of refraction is rarer medium is 90 degree. Okay, suppose that अगर कोई रे हमारा एक रेयर मीडियम से डेंसर मीडियम में मूव कर रहा है, ठीक है, और एंगल ऑफ इंसिडेंस जिस एंगल ऑफ इंसिडेंस के लिए एंगल ऑफ रिफ्रैक्शन का वैल्यू 90 डिग्री होता है, दैट पर्टिकुलर एंगल ऑफ इंसिडेंस इज कॉल्ड द क्रिटिकल एंगल. ठीक है, एंड द वैल्यू ऑफ क्रिटिकल एंगल डिपेंड्स ऑन द नेचर ऑफ टू मीडियम इन कांस्टेंट. ओके, so here we have one figure. One ray is traveling from denser medium to rarer medium. Okay, I think मैंने कुछ wrong बोल दिया है. When our light ray is traveling from denser medium to rarer medium, it bends away from the normal. Okay, so if I increase the value of angle of incidence, okay, this will be your angle of incidence. So if I increase this value of angle of incidence, then the value of refraction, angle of refraction will also be increases. That means this यहाँ से जो आपका रे आने वाला है, refracted ray like this which is bent away from the normal, जैसे जैसे आप इस वैल्यू को इंक्रीज करेंगे वैसे वैसे ये जो आपका refracted ray है ये और बेंट होता चलेगा away from the normal, and the condition reached where this value of angle of refraction is equals to 90 degree. Okay, so जिस एंगल ऑफ इंसिडेंस के लिए एंगल ऑफ रिफ्रैक्शन का वैल्यू 90 डिग्री होगा वो पर्टिकुलर एंगल ही आपका क्या कहलाएगा, क्रिटिकल एंगल कहलाएगा. ओके, सो फॉर फ्रॉम स्नेल्स लॉ we have mu2 into sin IC equals to mu1 into sin 90 according to this particular diagram. So mu1 upon mu2 equals to sin IC upon sin 90. The value of sin 90 is 1, so mu1 upon mu2 equals to sin IC, or 1 mu2 equals to 1 upon sin IC. Okay, Here we have some critical angle of some transparent medium. For water, refractive index is 1.33, critical angle is 48.75. For crown glass, refractive index is 1.52 and critical angle will be 41.14. Dense flint glass, refractive index 1.62, critical angle 37.31, and for diamond, refractive index is very high 2.42 and critical angle will be 24.41. Okay, next one is the total internal reflection. Okay, total internal reflection is another phenomena of light which is based on the topic which we have discussed, that is critical angle. Okay, so here we have one diagram. Here the ray is traveling from denser medium to rarer medium. Okay, so as I increase the angle of incidence, okay, this is your condition. First, the refracted ray bent away from the normal. Again, if I increase the angle of incidence, the refracted ray will be more bent away from the normal, and at the critical angle, the ray the angle of the angle of refraction will be 90 degree. Okay, this will be your refracted ray. एक्चुअल में होना ये चाहिए था, बट अगर हम क्रिटिकल एंगल की बात करें तो ये हो जाता है हमारा 90 डिग्री. ओके, रिफ्रैक्टेड रे हमारे एंगल ऑफ रिफ्रैक्शन हमारा हो जाता है 90 डिग्री. ओके, एंड बियॉन्ड द क्रिटिकल एंगल, अगर फर्दर हम क्रिटिकल एंगल के आगे एंगल ऑफ इंसिडेंस को इंक्रीज़ करते हैं तो होता क्या है कि ये जो आपका रिफ्रैक्टेड रे है वो सेम मीडियम में रिफ्लेक्ट हो जाता है. ओके, टोटली रिफ्लेक्टेड इन द सेम मीडियम. दिस फिनोमिना इज कॉल्ड द total internal reflection. This phenomena is called the total internal reflection. Now see the definition. When a ray of light traveling from denser medium to rarer medium is incident at the interface of two media at an angle greater than critical angle for the two media, the ray is totally reflected back to denser medium. Okay, this phenomena is called total internal reflection. Okay, I hope you understand very well. Next one is the necessary condition for the total internal reflection. The ray incident on the interface of two media should travel in the denser medium. Okay, and the angle of incident should be greater than critical angle for the two medium. Okay, so these are the necessary condition for the total internal reflection. Okay students, so the total internal reflection in nature have some technological applications. The first one is mirage. It is an optical illusion occurring in deserts and on roads on a hot summer day. ओके, कभी कभी आपने देखा होगा गर्मी के दिनों में जब आप रोड पर ट्रैवल करते हैं तो हमें आगे काफ़ी डिस्टेंस पे पानी होने का एक भ्रम जैसे होता है, दैट इज़ कॉल्ड माइरेज. ओके, सम tall objects such as trees appear to be inverted. Due to mirage, the person get the wrong impression of water. Okay, on hot summer days the air near the ground becomes hotter than the air at higher levels. Okay, the refractive index of air increases with its density. Hotter air is less dense and has a smaller refractive index than the cooler air. Okay, okay, here you can see the figure. If the air currents are small, that is the air is still, the optical density at different layers of air increases with height. As a result, light from a tall object such as a tree passes through a medium whose refractive index decreases towards the ground. Thus, a ray of light from such an object successively bends away from the normal and undergoes total internal reflection if the angle of incidence for the air near the ground exceeds the critical angle. To a distant observer, the light appears to be coming from somewhere below the ground. The observer naturally assumes that light is being reflected from the ground say by a pool of water near the tall object. Okay. Okay, the another phenomena is optical fiber, and optical fiber is a thin tube of transparent material that allows light to pass through without being refracted into the air or other external medium. Optical fibers make use of total internal reflection. Okay, so you can study about the application of total internal reflection with the help of books. The another applications are diamond looming, praise, and so on. Okay, so you can study with the help of NCRT books. Okay, so this is the end of the reflection or refraction of light. Okay, now in next topic we will continue with our next spherical surface, that is lens. Okay, thank you so much.